Le sprinkler techno.
Okay, this week on the sprinkler, the technical sprinkler techno, I'm not exactly sure if we actually have an English name. One of my favorite people in the world, Darlene Wilson. I've known Darlene for like 17 years. We've worked together for long parts of those 17 years. Right now, Darlene is working on implementing and trying to implement all sorts of parts of DevOps. And right now, our interests are around DevSecOps. So this is the subject we're going to be gravitating towards. So we'll just have a conversation. It's just free form. We will learn what DevSecOps is, because DevSecOps to me is sort of a mystery. It's always been sort of imposed at the end of whatever we need to do. Oh, what about security? And I know that that's not the point. And security is important and it's difficult. And if you think coding is a problem, then coding securely is even more of a problem. I have a quick anecdote and then we'll start talking from there. In 1996, I think, there was a guy called Marcus Ranum who used to be in charge of the firewall toolkit. And at that conference, he tried to sort of live write some secure code for a protocol or something. Him and another guy, I'm thinking Tom Christensen, but I'm not sure. So they're both pretty good coders, and Marcus is a coder, as a security coder, and within 10 minutes, he'd made mistakes. He'd said things, oh no, this will break. Yeah, that will be a problem. So I'm thinking, if you're an expert and you make these kinds of mistakes, for a guy who needs to deliver something by next Friday, it's even more of a problem, right? Because that's not the thing that you keep on top of your head all the time. So how do you get software to be secure without making people cry is basically my question.
What happens if you enjoy making people cry? Right?
That's a whole other issue.
There you go. So thanks for having me, to both of you,
pleasure.
Pascal, JP.
You're welcome.
I can't believe I've known JP for 17 plus years, because I would have been in high school, I think, at that time. But yeah, so I started my career as a developer, did about 2 years as a developer, usually gravitating to, team leader, work stream lead before there was agile, things like that, roles. Became a manager about 10 years ago, probably wrote my last piece of production code 10 years ago. And since then have worked a lot about evolving teams with their better agile processes, leading towards just DevOps, which we started to try to do stuff like that out of pragmatism before there was a term for it. And then I found out there was a term for it in about 2011. I was like, oh, wait, this is what we're trying to do, right? Bring Dev and Ops closer together. And then from there, I had the privilege to work with a lot of a couple amazing cybersecurity people, and who taught me immensely how important security is. It's just another quality metric, but it's one of the most important that we have. And I sucked up everything I could learn from them. So I would say for about the past 7 years, I put security in there with good software practices. And I don't think that there's kind of a DevOps without a DevSecOps. It's a bit controversial out there whether you need the sec in the DevSecOps. I think we hopefully in about 5 years we'll drop it, and we're just going to say DevOps, and security will be implicit in that. But that's basically my background, and that's my passion areas. I'm in the middle of studying for my CISM, which is Certified Information Security Management, which is kind of, hopefully that'll help with the overview of implementing all of these things across. But yeah, so that's my background.
Great. For the DevSecOps, the sec part of it, I think just like Agile needed to be there for reconciliation or removing the gap between the business and the developers, we needed something between operations and development. And probably now we felt that there was a bit of miscommunication or avoidance of communication sometimes between those two departments, the development, ops, and security. So I guess it's to somehow bring awareness a little bit more towards that,
Yeah.
shift them left a little bit, because it's not at the end of the development that you want to know that you have security gaps and you need to do something about it.
And it's traditionally been like that, right? Because it's functional, and I go through this evolution often when I'm starting to talk to people about better testing, testing, shifting left on testing, and all of these DevOps principles. It's the same with security. A lot of these things 15 years ago, 20 years ago were hard to do because we needed production-like systems, which were very expensive, right? We didn't have virtualization, we didn't have containers, we didn't have. So as soon as we started to move towards that, technology kind of enabled us to have better practices and do things in a better way and shift left and move things more left. And actually that's something, if you look, anyway, so Gene Kim, one of the fathers of DevOps, wrote the Phoenix Project, which is probably one of the more famous books about DevOps, and everyone listening should read that book if they want to know really what DevOps is. And he's actually coming from a security background, just as an anecdote. He was one of the founders of Tripwire, actually. So Gene Kim, talks about having this, the technology and the architecture enables the cultural transformation that has to take place, and the cultural transformation that takes place pushes further the architecture and the technology that we use and the tooling. So it's kind of like the symbiotic nature, right? Or relationship where both are kind of supporting and pushing each other further. And so really I look at it like that. Like before, it was really hard to run these security tests earlier in the pipeline, just like many of the other tests, like characteristics tests, anything like that. But now we can and we should be pushing these things much further to the left and be doing them iteratively, right from the time a developer is coding on the laptop, right down to the, the deployment onto production, and then continuous monitoring in production.
Yeah. And the thing I think that's difficult for security is that Conway's Law will say that your organization looks like whatever your
software models your organization.
Yeah, exactly. Yeah. And when you look at how security is often implemented in companies, because it's important, it's like a separate vice presidency that doesn't go through normal channels or whatever. So they don't get integrated fast enough into the development. And I've seen many places that go in the last week, oh, you have to check security, and then everything cracks and creaks and nothing sort of works. It's the same problem, but it's almost intrinsic to the organization because they don't want to have the security people part of the development. They want to have it more closer to the presidency, as it were. Yeah.
Well, I think it's twofold, right? A lot of organizations don't have security people or enough security people to scale to work in development, right? Yes. So they're kind of like, they're a bottleneck. And that's actually in the Phoenix Project. This is one of the things. I mean, you have your Brent guy in the Phoenix Project, who's like the kind of the guy who does everything, and he's a bottleneck for everything. And it's learning that you got to get him scaled out. But the security guy, Gene Kim described him really well. He's got like the IBM tie and the white shirt and the clipboard, right? And he's literally like in there to step in at the end and say, stop, like, no, this will not go. And we also know that that doesn't work because our goal should be that we're trying to put our software into production, right? As fast as possible, but with quality, security, reliability, because that's when we create value for the company. That's when we make money, right? It's to have the features or the services we're developing when they're in production being consumed by customers who want them. And so security needs to also follow that. Now, it doesn't mean, so we end up in this like, this issue when we have those separate teams, right? Where it doesn't scale. Development now is moving faster than ever. So what's happening? There's a great sort of a meme. It's like the DevOps unicorn, right? And it's like basically pooping out rainbows, and the security is there kind of shoveling it, and it can't keep up, right? Because that's what's happened. So security must shift left. It must scale. And so how do you do that? And there's like multiple ways and multiple tools to start to do that. But it's sort of an imperative, because if you don't have security and privacy in your products, even if you're the smallest startup, this can kill you, right? If you do something like include third-party software, free open source software that has a restrictive license, that so many developers don't even learn this, right? If they include a license that's restrictive, or it's a copyleft license, and you include it in your software, great, you might have the best startup idea ever. You go and sell it, they come in to do the due diligence, They start looking at your third-party software, because any startups out there, I'm going to tell you, when you go to sell, the lawyers will come in and they're going to start looking at your free open source software that you included. And if you violated or included a license, a copy left, guess what? You don't own your source code. You must give it back, right? Free to the community. And so things like that are so critical. I mean, and to be doing those things iteratively at the beginning, educating your developers, making sure you have some tools maybe that evaluate the software you're including, the licensing, right? And also the patch levels is critical. And there's so many good options out there that are affordable, and they should be used, but it's so important, because this could, you know, I hear a lot of people will say, oh, but you know, we're just a small, like 2 pizza shop. That's great, but you need to know about security and licensing. And with the global situation, the global ecosystem we have today, it's critical. Yeah.
So if I sum it up, shifting left is more about bringing awareness to development, the development team, development people, but also using the right tools. Because let's face it, I doubt that we could ever have a security specialist in every single team. I don't know if you should agree with that or not.
So you have to, it depends where you're starting from, right? If you have one security specialist, security expert in your organization, depends how many teams you have, you can scale up, right? But it requires a culture shift. It requires like investment, right? The way you do that, it's actually, I think even, I don't know if it's Gartner has pointed out that there's a really great way to do this. And it's almost like you can follow sort of like having like a Scrum Master model who's like the agile, you know, I don't want to say gatekeeper, but like the person who keeps the rails around agile, right? You can do that with security. And if you start, you might say, no one in my agile team knows security. They know nothing. They know basics, right? They know like, we shouldn't have this port open because it's, it's a port 111 UDP amplification attack, something like that. So they might know basic things like that. But the thing is that you need to set up coaching and mentoring them, or you need to invest. And the way you can do that is by having one person in the team that wears the security hat, even if they are like in kindergarten on security, and they get mentored by your security staff. Hopefully you might have, depending on the size of your org, you might have 0, you might have 1. If you have 0, you might want to invest in some training for this person. But hopefully you have somebody you can bring in as a consultant time to time that will start to mentor. And really some of the things are really, I don't want to say they're basic, but they really are basic, right? Every team doesn't need to be a security expert. Every person on the team doesn't, need to have this high level of security knowledge from a technical perspective, but they need to know, or maybe need to have the tools to evaluate the FOSS software that they include in their development. They can take a couple secure coding courses, so they understand like what are like common things that you should not do, as a Java programmer, that will stop you from creating security holes. Simple other things like making sure that if you're developing like microservices, containers, whatever, you use a minimized operating system in those. Don't start with just pulling down the full-blown operating system that has every port open and every service running. Start with something like Alpine, which is a minimized software. So there's a lot of things, and these are things you could probably read around for one day in terms of best practices and implement those far left, and you're already going to stop some of the downflow, right? And then again, like the scaling out is depending how many teams you have and how many security experts you have, create that community of practice, or create a mentorship or a coaching where there's one person from each team who wears that hat, and that one security person or n number of security people that you have, support them. And in times when there's complex security issues or questions around threat modeling, or what's the right way to implement this like IAM or whatever, then the security expertise comes in. But there's like 80% of what you can do without actually having any real level of security knowledge. Yeah. It's more about the culture.
First thing that comes to mind when you say that, for me as a developer, is like just using prepared statements when you want to have a conversation or exchange data with a database. That's the first thing I think everybody learns. It's the classic of the classics.
Yeah. So there's quite a few courses, and you can just go out and Google them, right? Or like online trainings, or if you have access to LinkedIn on just secure coding for like whatever language you're using, if you're using Python, Java, whatever. And it's, some things are basic. That's going to help you like a little bit, right? But really, like in terms of other issues, like if you look at the security vulnerabilities of big exploits that happen, a lot of times that's happening because systems are not patched, because we're using either commercial software or open source software that we've deployed live, and we haven't patched it when there's been security patches, right? Like CVEs, like critical vulnerability releases. And if you look at like the Equifax big exploit that we had, right? Which I got caught in. So free Equifax for life, but still not fun. Not fun. That was because they didn't patch Apache struts. There was a severe vulnerability in Apache struts. They did not patch it. And guess what happened? They left it out there. And this is what will happen. And I think it's about those types of vulnerabilities and exploits that happen from an external actor out on the field. It's like 78% of them, some crazy number like that, are just because of unpatched software. So you don't need to be any sort of security expert to know you should have a robust patching system. You should keep your patches up to date, right? Just like on our home laptops, we want to keep updated with security patches. If you're operating software, if you're deploying software, you should make sure that you can patch. And that's just good engineering practices. That's good software, right? You want to be able to push a bug fix out fast. So you want to
be part of the company's hygiene, you know?
Exactly. So again, this doesn't require any special security knowledge. It's really about making sure that your pipeline is, robust, and that you can actually push things through with a good level of quality rather quickly. Now, but just having things out there that hang around unpatched for a few months, years, depends on the vulnerability, right? If it's a really hot vulnerability, and I mean, you can be sure you're going to get hit. So Equifax, I mean, look at how much money that cost them.
But the thing is that you see stuff like 2 weeks ago, the guy who was exploiting automatic the automatic dependency stuff. It seems that everybody's trying to make everything easier, and every time you make something easy, you tend to neglect aspects of security. That's when I was a sysadmin, the thing is that you can have things secure or simple to use. You can't have both. At some points, you'll need to go in and do something that requires time and effort. So if you look at the Java Maven stuff, it's managed by Sonatype, and they have like these groups, and they don't allow anybody to pick a group to do anything. They're sort of very meticulous on that, well, reasonably meticulous on that, because they did not get burned by that as much as the JavaScript people and the Python people.
Yeah.
And it seems to be that everybody wants security except for all the things you need to do to be secure, which is I think it makes the sysadmin and security people's lives miserable, right? And I was talking with one of my friends about the DNS exfiltration he was doing, like to get his information back. And you go like, oh, that's clever. But people in the administration and sysadmins have known this for forever. I have a friend that has like this AI-based system that looks at outgoing DNS requests to go like, I should not let this DNS request go out. But it complicates everybody's lives. That's the thing, right? It's anyways.
But I guess from a software production standpoint, right? Like where you're, I mean, there's the overly complication of your own laptop, right? If you were to put all this security stuff and have to implicitly say like, let this program connect, nobody would be able to use their laptops, right? Or most people would not. I know some crazy security people who have that level of control over their laptops, but I think it's just ridiculous. But I think what it speaks to is, again, it speaks to this. So one of the tools or like techniques or processes, I guess, that you can use is in your Scrum teams when you're going to be developing a new service or a new feature, that part of your planning, right? And part of your part of your planning is you look at, are we going to be developing anything like that is putting us at risk? Like you do like a threat analysis, a risk analysis, right? a threat modeling for that feature. Now, a lot of times it might be, yeah, there's nothing, it's quick, right? Like 2 minutes. And sometimes there actually might be something, right? You're opening up a bunch of ports, I don't know, you have some type of authentication, whatever. That's when you use those like security experts where you pull them in to help you, right? But you should be looking at that stuff early on. And at the end of it, it's always this balance, the risk versus the usability, right? And you might let some things go and say, you know what, the usability in this case is more important than the risk. The risk is we can mitigate it. It's not so much of a risk. And there's always going to be this balance because the most secure thing is unusable and the most usable thing is not insecure. So
exactly.
Well, like everything else in development and in IT, it's about trade-offs. You need to make the right choice, and you need to make those choices with enough knowledge to be able to make the right choice. Basically, it's always balancing, you know, the pros and cons.
Yeah, exactly.
You need to be in touch with your customers also, because what you might think is not a big deal might be an enormous deal for them. It's the same thing as all software.
Yeah, well, we're talking about security, but in there we also have privacy, and privacy is becoming a huge thing with GDPR in Europe and just new privacy laws and everything. And people are much more concerned about their privacy and how their personal data, their PII, their personal identifiable data is used. And there's huge fines under the GDPR. Not so many court cases yet to see how it's really going to translate, but still, like, when you're developing now and doing database modeling and just any sort of data processing, right? Managing people's, I don't know, like whatever you have from them, whether it's just their name and their address, anything that's personally identifiable, there's strict guidelines now that you or laws, not guidelines, that you have to follow. And it has to do with data retention. It has to do with logs. I mean, everything, right? And so, like it or not, organizations have to actually learn a lot more about security and privacy now, just because of the global situation.
2 meetings in the last 2 months about GDPR I've had. Sure. So it's a real thing. It's not just a passing thing, right?
So say I'm a developer and I want to be a bit more aware about what I'm doing, the cost of my decisions and stuff like that. Are there tools? You mentioned some training, but I don't want to necessarily promote one in particular. But I did Secure Code Warrior, free ads to them, because it was really good. I don't know if you know about them.
No.
It was about the whole OWASP, like the top 12 or 16 exploits, and you were challenged with code snippets, and you had to find where there was security problem and how to solve it too. So you needed to fix the code and submit it. It was really well done. So that could be a way to, you know, get you kickstarted on your journey to being a bit more aware about security stuff.
Yeah, agree.
But so if I have a large code base and I have not at all worried about security, or in that context, right? I've worried about it by not sleeping at night, not by what tools would you use? Are automatic tools any good, or is it just all human brain power?
No, I mean, it depends what your tool is. Like, is it, you know, web-based? Like it really depends on the tool, right? But I mean, there's many open source tools you could grab to do sort of like a pen testing, right? There's some proprietary ones as well. Some of the security tools are very expensive to do this test automation. I mean, Nessus is very expensive. You know, there's the tons of tools, but you can get a lot of tools out there from, like, even Syscat. You can look at like what they have, and there's people who have Syscat scanners. So depending what your product is, you could go and look for some sort of a tool that you could at least get sort of like, we call it like, it's kind of like M&M, you know, hard shell, like outside and softer inside. So make sure at least your shell is hard, and then address the inside. So one of the things we didn't touch on, but this is like the really close to my heart, is more around defense in depth. And defense in depth is taking that software security, you know, realm, but applying it even broader, because so many of the vulnerabilities or security incidents come from inside actors, right? Whether it's even a mistake, like just an accident, it doesn't actually mean they have to be malicious. They could actually just go in, and because somebody didn't take care to like restrict their permissions, right? To do a proper permissions modeling, they go in, they have permissions they shouldn't have, and oops, they go and delete something, right? And it brings, I don't know, whatever, they could delete a bunch of users or whatever. So that also happens. And it's not to say that all of these security events are from malicious actors. It doesn't mean every internal person is malicious. So what defense in depth is kind of starting from that inner core and working out, right? And making sure that, like, so for one, if you're a software house, 100 people, you hire people in, right? They get credentials on your system, they get access to your GitLab or your GitHub or wherever your source code is, et cetera, et cetera. You know, there's many tools there that you want to, or processes you want to keep in place to make sure that when you offboard them for whatever reason, they quit, you get rid of them, whatever, that all of those permissions get deleted, right? It seems very basic. But scale that out like to a 1,000-person company that maybe grew really fast and they never did it before, and there's someone manually going into GitHub and deleting accounts or deleting access to the repos. I mean, just something like that is like a very basic thing, but it's at the core, right? And you start to like move out from like the core to like everything else. So, you know, how it involves like how people log on, just everything from a defense in depth point of view. So you're starting not just looking at the software, but looking at how people access the software and trying to lock down every path. So basically, like if an external malicious actor gets in, they can't advance through the system because you've done this defense in depth where you've taken into account at every step. You know, a lot of people who are not operating publicly accessible networks used to say, oh, but our stuff is inside a protected network, so we don't have to worry about the security of our, you know, box inside a protected network. But that's not really true, because you can have a sysadmin that might be able to go onto it who is a malicious actor, right, working for whoever, or somebody, like I said, just, you know, by accident goes and does something that brings down your network because they had access they shouldn't have had. So all of those basic, all these building blocks that provide you with the defense in depth, and the kind of like the software security is one part of that. It's just one part of it. So it's quite holistic.
Well, the big things that have broken here in Quebec have often been inside actors, right? Yeah. And it's not remote people that found a bug in software. It's an entire process thing inside the house that wasn't managed.
A lot of times it's RBAC, right? Like people shouldn't have access to that part, or, you know, we've seen it a lot in the banking industry, right? Where people had access to things that they shouldn't have had access to, and with no oversight. Yeah, exactly. And I've worked in places where security is so complicated that at some point people take shortcuts. Yeah, I know I've worked on systems where I did not have a password because it would have been like the 17th different password I would have had to get. And I was using somebody else's password because somebody gave it to me because he knows that it's going to be another 2 weeks before I get it. So I get that password, and at some point everything gets complicated. So here you get into like, try the best you can to keep it simple for everybody, right? I mean, if I have to know 5 or 6 passwords on the company I'm working at some point I'm going to be doing something stupid. It's going to be written down somewhere. It's going to be put on the wiki,
something like that.
But exactly. So those are exactly the points, like when you talk about defense in depth, right? Like, it sounds crazy, but don't put passwords on the wiki. How many? But I would ask, like, your listeners, how many people have done that, right? It's because it's easy and we do these things, and there's a lack of security awareness, or there's a lack of even belief that, oh yeah, but that one password could be the difference between an external actor getting through and being able to advance an attack, or getting hit at a door and not being able to advance an attack. It could be that they, you know, got onto your Confluence page or whatever Doku wiki you're using, found a password and went and tried it, and it worked somewhere, and now they have another door to get in. So that's why defense in depth is so expensive, so important. But and probably expensive a little bit to put at all, you know, there's a cost to this, right? But one of the other things, just from a developer point of view, that I would really encourage is, you know, any sort of secrets, keys, passwords, whatever, should always be stored encrypted. How many people have them in, you know, especially for the headless accounts, right? The machine to machine, the automation, the test automation accounts, and all of this. A lot of times those credentials are stored in plain text, you know, in the source code itself, right?
Of course.
And that is a really bad practice.
I know.
Absolutely. And if you look, I mean, there was like 2 years ago, I think, one of the other banks in Canada got hit with that. I can't remember which one it was, if it was National. I don't want to, anyway, it was one of the banks. There were basically like hackers, right? Looking for source codes stored into some of the generally known source code repositories, right? That had credentials for CI machinery. So for Jenkins, they were looking for GitLab credentials, Jenkins credentials, anything like that, because they know if they can get in there, they can maybe start injecting code. They can start doing something, they can hijack, right? And they were specifically looking for credentials from financial institutions who are using, you know, all of our good automation practices and everything. So one of the things always, it's so easy to put the passwords in and the secrets and the keys and everything. They should always be stored separately, encrypted, using something like Ansible Vault, something like that. Really, really important.
Yeah,
and not so trivial to do.
Exactly. It's sort of a decision that's sort of there's a couple of problems with that. You start by a small project and you have your files you have them in there. I mean, every place I've ever worked, it's always, so what's the password? You start looking through property files and stuff, and you go, oh, that's a password. Why? Because there's a star and a $sign in it, so it needs to be a password. There's no reason why somebody would put that. So you figure that out. And then at some point, you decide, hey, we should have this. And then it goes to sort of a committee, the security committee, that will decide on how security will be managed. So it's taken out of my hands, but until they come up with a decision, I have no option, right? And the more time I spend trying to figure out I know how I would do it, but now the committee, they're far away from me. They're going to be done in a year or 6 months or whatever. That just amplifies the number of passwords that will go into the wrong place. And it's sort of has this effect where it deresponsibilizes it. Then you think, oh, that's not my problem anymore. There's other people. That's why I like all the DevOps ideas, where it's not just DevOps, but it's your responsibility. It's not somebody else's problem. It's your problem. You should probably, if you think it's wrong, then do something instead of just exploiting it, as it were. As I have often done, right? I'm not more honest. I'm not more
less lazy.
What?
Less lazy. A lot of times, listen, we're lazy, right? Like, we also want to do things easy and fast because we have 50 other things to do, right? And we have to get our feature out. So I'm not going to sit here and figure out how do I don't know, like, encrypt these passwords. I just need to get my feature out. I need to deliver, and that wasn't one of the requirements, right?
Exactly.
So this is where some of the stuff starts as well. And I agree. I mean, it's a balance, but knowing what you're doing and taking a conscious decision, a mitigated risk, or saying that, you know what, all of our source code is housed on our own servers inside a, you know, really well protected network. We're not out on GitHub. We're not storing it in the cloud somewhere. It's like whatever. So this is very low risk for us, whatever you think. I mean, there's always a risk, but if you identify them and say, look, the cost to do something like Ansible Vault is going to cost us, like, I don't know, however many weeks of work for however many teams. And what's the benefit? You might say, you know what, that's not a priority, right? Because we still have to deliver features. And that's the reality. I mean, we're in a business that we make the money when the feature is deployed. So, but you need the feature to be somewhat secure and somewhat with the right level of quality. So it's the right security, right level of quality. And those are the decisions that you need to take, but it's important to know what you're not doing and why, and then take the decision, right? Yeah.
That's a big problem to me, what you just mentioned, because it is true. And I constantly have to fight that. as a technical coach or agile coach or DevOps coach, it's always the same. We want to improve the situation. We want to improve the practices. We want to bring automation. We want to do more continuous integration, delivery and stuff. It doesn't come free. You need to invest time. And people are saying, well, the client doesn't pay for that. He pays for functionality. But you know what? Functionality cannot spawn itself into life. It needs infrastructures. It needs servers. It needs all kinds of stuff to make sure that quality is controlled, security is controlled, and the environment to be able to be operated into. So we need all of those things to support the creation of value to the customer. And even though it doesn't really shine every day in the eyes of our customers, it enables us to bring value more securely with a higher level of quality and eventually faster to them in their hands. But we need to build that, and it doesn't come free, you know?
So one of the things that's interesting about that is it's these choices, right? But if you think of quality as part of the feature, as part of the functional part of the feature, we can look at something like Netflix or look at the Apple TV model, right? So Netflix early on realized, and Netflix has been streaming for, I don't even know how many years now. It's at least what? Oh God, time goes so fast. I don't even want to say. It's got to be at least 6 or 7 years. But
10 years.
Is it 10 for Netflix?
I'm pretty sure it's 10.
So if you remember when we didn't all have, fiber to the home or high bandwidth, you would start your Netflix video, and even sometimes now too, if you've got 3 kids in the house and everyone's streaming, but it always starts, right? But it starts with a degraded quality. It starts with whatever, but it starts. And then eventually, as it starts to buffer, it'll catch up, within however many seconds or minutes or whatever, right? Apple TV took a different decision. They won't start it unless it's the top quality that you've asked for, right? And so then a lot of times on Apple TV, what you ended up with is you go to rent a movie or watch something, and it's like, oh, it's going to take an hour to download. It won't even start, right? It won't start because they don't want you to buffer, but they don't want to show you a bad quality. And those are 2 different business decisions. I would argue that Netflix made a smarter decision in that the people want to see the video right away. They don't want to wait even 5 minutes to see the video. They would rather see the crappier quality and complain, oh, it's not whatever, but at least it starts. And so it's the same thing with our software, right? We have to know what our business is. And if we delivered stuff that just didn't start, well, you might have delivered your feature, but you're not going to be around very long, right? Exactly. It's like Twitter in the early days. I remember JP, we would joke about it, right? I mean, Twitter, the downtime, the whale, right? Was what did they have? 5 6s maybe, or I don't know, talk about no 5 9s, right? I mean, if they had a 50% uptime, that was good. But for Twitter at the time with the user base, that was acceptable. People were willing to try and invest, right? But if your Gmail's down for 24 hours, can you imagine if Gmail was delivering quality that was like that, or any of the Google apps that everybody is using for, my life is in Gmail, right?
Yeah, exactly.
Exactly. So this is just yet another metric, right? And the thing about security is the awareness part helps you take those better decisions based on the risk. But you need to be aware, because otherwise you'll just be caught off guard, and then you've not been empowered to own your decisions.
Another example of temporary service degradation would be how Windows changed their strategy to boot up a bit more faster, right? Before they were trying to charge everything up front, and then they realized, well, we don't need to do that. I don't know if Chromebooks that open in a flash of a second put some pressure on them to boot faster. I don't know if it came from that, but they just decided to change how they approach things, and now Windows is booting super fast.
Yeah.
Well, about getting consciousness in that, the only tools I've used, I think, for that are SonarQube and what's the other one? Veracode. That's
so for static code analysis.
Static code analysis, and that I think gives you sort of an idea of what's to do in your code. The criticism I have of that, though, is if you run that on a legacy system, you get such a high number
Yeah.
that at some point you go,
Yeah.
we've been working with this for a long time. So I don't know, how do you get the people on your team to not only be conscious of it, because they'd be conscious of disaster, potential security disaster, but to actually think that they should fix it. That's sort of there's a sort of a lax attitude that sort of builds. If you have a mountain, if I give you 279 security bugs and you've been online for like 4 years, then you'll go like, then we're okay. How do you get people to go, I think we could do better on this, and I think it might help our code?
So I would say the same way with any technical debt. Security debt is just like any other technical debt, right? And you know, it's like having the credit card statement you never open. Once you open it, you gotta start to figure out a way to address it. And probably if your credit card statement's like $20,000, you don't have $20,000 hanging around to pay it off all at once, right? So you're doing like $150 a month, something like that. So it's the same thing. I mean, and you're right, like any of the security tools, I mean, SonarQube is security adjacent, I would say, you know, so it does the static code analysis, does code checking. You can also put guidelines for code structure that you want to have custom. So it does a bit more and a bit, you know, it's security adjacent. But it's the same thing with other security tools. If you run them against your stuff, you're going to get piles of data that you might even probably have no idea what to do with, right?
Exactly.
So in some instances, you need a security specialist or expert to come in and kind of look and weed through. That's where their expertise comes in place, right? Anyone can run the damn tools. It's not so hard, but actually configuring them to get the right stuff for your business model, and then actually going through and saying, oh, this is like a false positive, or this is okay, this is low risk, that's another thing. But on SonarQube or any sort of technical debt when it comes to, you know, the code or missing tests, like automated tests, whatever, you gotta triage it and say like, okay, there's 1,000 issues here. Maybe we'll look through and find 10 that we really should fix, and the rest we're just gonna say, like, just keep it buried, and because you'll never get to it, right? So I think like that's the other part, is there has to be a realism around, like, you can't, it's what's the Voltaire, you know, perfect is the enemy of good, I think is the statement, right? So it's always that balance. Now, going forward, what you want to do is educate the developers and the teams, right? And other people in the org, by the way, right? Like the product owners and the managers and everybody else, to understand the importance of security and how to take those risk-based decisions, right? Because you're not going to do everything. And then just some general practices, like just including, like I said, something that does your free open source scanning, like when pulls up out through your Maven files, looks at all of the open source you're including, and basically right on your screen as a developer in Eclipse, you get a box that says, oh, this is like a GPL license, this is approved in your organization, and this is, oh, good for you, you took the latest patch level. All good, green. Or, you know, you've included a copyleft license, this is big red mark. Maybe you can, and from there you could even, if you wanted to go further, you can block a developer from integrating that code, right? From doing a Git pull, stop them from doing it based on, you know, hey, you know, so just even that, some of those tools that you shift left with raises awareness, even if you haven't even told the developers what you're doing, right?
Yeah, exactly. I get what you're saying.
Yeah, but again,
I think
technical debt, there's no magic to technical debt, right? Either you invest in it within the teams, or you put a side team together to invest. I don't like that model, but you put a team to chip away, but or you leave it.
My problem with DevOps and DevSecOps and sort of these separations that people make is that they view them separately, right? So if you have technical debt, call it what you want, like the code is not correct in certain aspects, and you have security, that's two pools that you need to pull from. And people, I don't think, understand the subtleties of maybe the relationships between the two and these ideas. So it's very difficult for me. I'm not good with people as a general rule, but for a manager, if you're going to have to explain to him, this is technical debt and this is security debt, I think you're just creating a wall in his mind that now he needs to manage these two things. And
It's all it's all technical debt. It's all
No,
technical
exactly,
debt.
I agree.
I
with
really
you.
like
Yeah.
I really like that you place them all in the same bucket, because to me that's what it is. Anything that is not production ready or production quality level ready, and regardless if it's defects or missing automated tests or security requirements that are not met, you name it, all that to me is technical debt.
And my last thing that I dislike about the tools, but it's not the tools' fault. The tools are doing what they're supposed to do. The last thing, and this is true of SonarQube and Veracode, is that people see lists and they will try to destroy the lists instead of fixing the problem. So if I'm going to go with SonarQube because I've seen this more. If somebody can find technical debt like bad variable names, he will go all over there and change all the variable names, reduce what SonarQube reports, and view that as a success. Same thing can be done in security. If you go in security and you say, we're going to boost every version to the latest version, I would think maybe 2/3 of that effort is for no reason, right? And I think tools sort of reinforce those bizarre metrics that people view as important, like your code should have 90% coverage and unit test coverage, that annoy the crap out of me, where you just want actually to get
90%. It's 100. It's 100% coverage.
It pisses me off to no end, because people start chasing the number instead of fixing the actual problem, which is maybe think more about what you're doing, right? That's the underlying message of 2,000 things to fix in Veracode, is think a bit more and think of upgrading your versions, and think doing it every day instead of doing it on that month and then having a drop like this in the numbers and you go like, yeah, we've succeeded. You haven't really succeeded, because 6 months from now, you're going to be going back up and you've not learned anything.
Yeah. I want to do a little pause because you just brought something that's very interesting. And it goes back to what Darlene was saying about everything being in symbiosis, you know, when you want to change those version to be the latest version. Some people would argue that, well, we need to retest everything. But then when you have test automation and you have continuous integration and you have your pipelines and everything, well, you know, keeping up to date doesn't cost you as much because you have automated so many things. So everything is in symbiosis. It's a great example. And I just thought of that while you were mentioning the version example.
Well, it goes back like to what I had said at the beginning about putting the code into production as quickly as possible, but with quality and security, right? If you take it from that aspect, putting the code in quickly means that you have levels of automation, right? It doesn't mean, of course, you don't automate things that are either way too expensive to automate, and there are things that you might choose, we can't test with that system, right? Like it's going to cost us too much to mock it or whatever, right? But the thing is that that's kind of that goal that you should be going for. And like JP, with like what you're saying is, and this is often a problem with anything we measure, right? Anything we kind of measure that you can put a number to, like, or a KPI to, is that we lose sight of what's the goal of what we're measuring versus that number. And I think that tends to be like a management problem, right?
It's a vanity metric.
Exactly. So like if you have 1,000 things in SonarQube and you cut out 900 of them by doing something that really was meaningless, that might look good to people who don't understand what you really did, and you still might have 100 issues that are actually the more important ones. Exactly. So again, it's always the same thing, right? It's always about what are we doing that is adding value, and you have to triage the stuff and prioritize it, and everything won't make it. Then that's the reality, right? We would love to live in a utopia where everything gets built in from the beginning, where we have like, you know, a 6-month like runway that you put in all the CI and you get everything perfect for the developers, and then they start and they all are you know, full stack developers doing their own IAC, like everything always green, you know. And that's a utopia that doesn't exist, because we need to put features into production, right? We need to make money.
This comes back to the separate vice presidency for security, is that what they say goes, right? So at some point, if the vice presidency decides you need to do A, B, and C, that's going to be the law, because that sort of gets to the point where if you don't do it regularly, then at some point the vice presidency will say, drop everything. I don't care, whatever you're doing, drop it. You have 72 vulnerabilities that are high. Please get them all off and that takes time. And I think I understand why there's a separate vice presidency, but it would be fun if they would be earlier in the process, which is the shifting left. I understand this, but they tend to see the result at the end and complain at the end.
But this is like scaling anything, right? In software, it's you need to do it earlier, and as Judge Humble says, if it hurts, do it more often, right? So I mean, the security, it's no different. Like I said, like that's why I call it just another quality metric. Not to minimize it, but actually to like give it more power, to say that it's not something special, it's something that should be there. It's not kind of something that we bolt on at all. And in the past, yeah, we always did. And like I said, there was challenges to be doing it much earlier on, not only competence, but also just technology, right? And now, I mean, you can do 80% of the things iteratively early on and with little pain, you know? It's much more painful if you're going to, you know, put a new feature onto your website, or well, not website, but onto your platform, whichever it might be, and you find a huge security, or security finds a huge problem at that point, right? Because it's gonna, as we know, it costs so much more to fix it.
The thing is, it's all about collaboration to me. Like people from security needs to know why development need to have access to this, and that, and people from development needs to understand why they shouldn't have some of those access. And it's about trade-offs again, and it's the word of the day, I guess. But you need to make sure that everybody's aware of the objectives, the risks, and what's at stake. And once we have the global picture, then we can start making decisions because we're aware and we know where we're going and what we need to be able to be successful on every single side.
Yeah, you need to integrate security into your entire development flow, all the way from, you know, even having product managers who specialize in security. I mean, if you have something that's on a cloud platform, probably want a cloud security person, right? Or a cloud security architect, because they're going to actually know a lot more. It's an important role to have, but it should be there in the architecture, because for sure, implementing like a bad IAM architecture, and then you find out at the end that there's all kinds of security problems, so that's going to cost you a lot of money, right? But some of the other things that are so much easier, so not so much easier, but easier to do, and just put them in place iteratively, that don't change that much. You know, port scanning doesn't change that much, right? We don't have 50,000 new ports coming every year, right? So checking basic ports that for your business model that you know should not be open, right? It's always that law of minimization, right? Do the minimal, take the minimal distribution you can for your operating system, have the minimal amount of services running, right? And then, so if you start from that and you only open up as you need, then already you're taking a different security approach, and that doesn't really cost you anything, right? It's the difference of pulling down something like Alpine versus pulling down a full Red Hat version, like distribution. So those types of things, and having the port scanner, you know, maybe it takes a couple weeks, or maybe you pull something off the net and integrate it into your CI, but then you start scanning your code all along the pipeline for those ports. That can cut down a lot of issues that might arise, you know, and that's pretty basic.
That's a good example of something you could shift left. Do you you said that around 80% of what we have to do can be shifted left. Can you give us a few examples and maybe explain a bit some of the tools that made that possible?
Yeah, so for sure, I mean, the port scanning is a great example of that, right? And again, a lot of these tools will depend on the business models that the companies have or the developers have. It's going to be different, right? Different sets of tools. But I mean, the port scanning, then there's like penetration testing tools that you can shift left. I mean, like I said, there's some of them I can name, like a Nessus scanner. You can look at, like for Syscat, at the Syscat all their test metrics kind of thing, or tests, not metrics, but the list of all the tests, and you could automate that yourself, or you could look out externally. I mean, I would say that if you're taking security tools that are third parties, free open source, be very careful about them. Make sure you're taking something reliable and that you're looking at it. I think that, like I said before, the open source and the third-party inclusions of software, right, is really important to have early on in the pipeline. There's 3 tools that are like top notch on that: White Source, Black Duck, and Snyk. They're all commercial tools, but there's also some free tools out there too, right? That do that will at least alert you to compliance issues with licensing compliance, which I said that could be disastrous for a business. And that's just a simple thing to actually do at the beginning. It's painless. And also it will check the versions, right? So you make sure that you're not pulling down a version and including it that is one at the point of inclusion, not the latest. You should probably always use the latest, but that it doesn't have any security vulnerabilities, right? So things like that early on. What else? I mean, that's kind of like called like FOSS auditing, or like, like that type of thing. I mean, when you're talking about in production, that's a different story, right? You have like security incident event monitoring. Elasticsearch has just released last year, I think, like a huge component that does that. There's HP ArcSight, like all these tools that will monitor, but it really depends on your business model. If you have something that's distributed across multiple clouds around the world and you have multiple nodes, you probably want something like an ArcSight that's monitoring off of each box. But this goes into like a huge O&M implementation around your monitoring strategy, your logging strategy. And that's where a security product manager would come in, right? To say, what's our strategy for log retention, for monitoring from a security perspective, as well as a regular, like, O&M perspective. What else can be shifted left? I mean, like, if, so the other part would be that as part of this is not so much a tool as a process. Like I said, do the threat modeling and the risk analysis every time you start a sprint, right? It could take as little as 30 seconds. Nope, nothing we see, and that's it, you move on. Or you might have to do something a little bit deeper. Based on that, you might have to write some security tests for the code you wrote. So those should be automated just like any other test cases. Your unit test, your feature test, you should have security feature tests for the feature you're developing in that sprint.
It's a good mentoring opportunity right there, to have people from security come and sit with you and start building a strategy to automate some tests.
Yeah, so for sure, when you have in the teams low level of security awareness and knowledge, that's where you leverage the security experts, is in the threat modeling, the risk analysis, and then in maybe helping you identify what are the tests you should write, right, in the automated way. So that's another big way to shift left, is just to be doing that at the beginning of every sprint. So the automated tests, the pen testing, again, like these are tools it might be as fast for you to develop something in-house as go out and source something, right? I'm just trying to think, like, what else is there? I mean, right there, you're covering 80%, you really are. With the static code analysis and those tools, another important tools to have in place.
That's great.
Yeah.
So if you get that anyways, at some point, people are going to get it in their head that they should be doing it, right? If you get, once in a while, you get a warning saying maybe that's not the right version, that will start people thinking about that more on a daily basis, right? Yeah.
And the other thing is, if you work for like a large company or a company that is in an industry like banking or military or anything like that, you're going to have really much larger security rules and regulations that you have to follow, especially in the banking industry, right? So the software you make for, like, I don't know, whatever your little app on an iPhone to, I don't know, count whatever, versus your banking app. I mean, they have very different security regulations. So you also have to know, when we talk about the security tooling and shifting left, well, if you're in banking, you have different organizations that have the security guidelines, right? So you'll want to automate those and shift those earlier to do those types of checks, right? So it really depends the industry you're in as well. So
you keep mentioning financial institutions. I'm going to say medical institutions and pharmaceuticals are the absolute, I'm going to say nuttiest, but with affection. They have specs on everything.
Yeah.
What about SpaceX?
And so one of the
Tesla.
things in that is where you go between security and compliance, right? Like it's kind of like you can call it security or compliance. You might have compliance bodies that you have to comply to. And in those, again, if they're very industry or product business specific for you, you might implement them on your own. Maybe you have 200 compliance like test cases or something that the security got, and basically look at what, and if you were running any security tests or there was someone doing that manually, right? Look at automating whatever that person was doing and get that security person actually mentoring and doing the more value add with their expertise and not just kind of like pen testing or doing something like that.
Pretty much.
Yeah.
I'd like to hear you a little bit about software security practices. I'm pretty sure that, well, I'm not aware of them, and I would like, because I know for development, for architecture, and design and quality, we have a bunch of practices that we can learn and follow. I would call them engineering practices, like TDD would be one. There are many of them. But for security, is there such a thing?
I don't know. I mean, there's secure coding guidelines in any language that you're working with. I think knowing those is kind of important. But I really think it's more around, and JP, maybe, I'm saying this as someone who hasn't coded for like 10 years, right? So I'm a teaching, not doing. But I think the practices, again, are very similar to things like TDD. Security is just another quality metrics in there. So your security should be thought of up front. You should be doing those test cases up front, right? Before you implement your feature in the exact same way. So those types of the shift left practices are probably the most important for security to be successful. Otherwise, security is not so different than any other technical area. It's just really about making sure that like we did so many years ago with having external like I&D and QA teams, where they're like at the end and getting the test cases and executing them and throwing them back. You're doing now the same with security, as you're moving it like backwards and integrating it throughout the organization, throughout the development cycles, throughout the pipeline, and scaling it. That to me is the most important. It's the awareness, the cultural change, and the scaling of it, because that's the other part. You will never succeed with you'll never be able to keep on top of what, security threats are coming. Never. You'll never be able to, because I mean, it's completely automated, right? It's completely AI driven. You'll never keep on top of it. You won't be able to plug your holes. So you need to kind of scale it. It needs to be scaled and it needs to be built in from the beginning. I would say that that's more important actually than actually having all your developers know secure coding, because your secure coding guidelines you could catch through something like SonarQube or through your tests, So, but maybe that's a radical thought.
I've always thought that if you're doing web programming and you haven't read OWASP, then you're doing something wrong. So that's the whole thing, right? It's such domains, there's such specificity to where you're working, that at some point you need to understand how that works. If you're working in telecom and you haven't seen what the problems are with SIP and how people can influence the protocol, then you probably shouldn't be coding using SIP. And it's pretty much all the same thing, right? If you're developing an Android application and you don't understand that somebody could come and steal your data via another application, you should probably be reading up on that.
So I'll challenge you and say, like, especially for the OWASP, right? That if you haven't done it, but I've created a structure of automated tests that are validating your code as like, you step in your developer day one, right? And you're pushing code out to production. For example, I mean, that's the Netflix model, right? You start there, day one, you have code running in production. Why is that? It's because they have such confidence in their, and I do want really dark here, so I should probably turn on the light. They have such confidence in their test infrastructure and the robustness of their tests that in a way, now I'm not saying that their developers don't know these things or whatever, but I'm less concerned about the guy on day one making a stupid mistake that he might very well make, because I've got this layer of protection around. So it's kind of like this thing we say, trust but verify, right? Like that that old Russian proverb. And I would say that's the same thing. So you're going to have out there a lot of developers who have no idea what OWASP is. or what PCI is, right? For the credit card industry, or whatever other standard that is out there that you're supposed to be aligning to. And so it's better to have, it's like the example you gave at the beginning, right? Like if the security guy making mistakes as he was coding. Well, you know, if you had the automation there, then, you know, you understand that people are going to make mistakes, right?
Yep.
That's the value of automation.
Cool. Well, you've lost your light.
Yeah,
we don't see
so
you
do I
very
get
well.
up? I don't know what you guys want me to do. Do I get up and go turn on a light, or?
Yeah, I think it would be better because we don't see you anymore. And for the people who are watching on YouTube,
yeah, I
they
know,
can't
exactly.
enjoy your presence anymore.
Which light will I put on? No, not the one right over me. There, that's better.
There you go.
Not the one. Sorry,
and there
everybody.
was light.
Yeah.
All we were seeing was your smile.
My teeth are so white. That's my smile and the things. Yeah, so that would be like my challenge, is like to say that, you know, in a utopia, our developers actually all know all these things, you know, but the reality is a lot of that stuff is learned as you go, right? And if you have the framework where they can make stupid mistakes and it's caught because we have a robust infrastructure, they're going to learn actually through that.
But I take your point about Netflix, but I also understand, we must also understand that Netflix has more than 20 developers, right? So there's some people that are actually specialized in that, and they will do the work and everything. If you have a 20 developer shop, at some point, they're all being stretched in all directions.
Yeah.
And but again, most likely some of the great in the business too, right?
Yeah.
Well, but the same thing. So if you have a 2 pizza themed shop, right? Then it's you have to know your business, what's important for your business. You hope that somebody there knows that, you know, if you're, like you said, if you're developing web, that they know what OWASP is and they know that they, you know,
exactly
what to do. And when new people come in, one of the first thing they do is, okay, so here's your, you know, here's your login, here's your whatever. And, you know, if you don't know this, you better go look at it, you know, learn this, right? But also putting some of those checkpoints into the test automation, not so hard to do as well.
I'm not going to argue against automation, right?
No, I know that. Yeah, I like the trust but verify. That's my new thing.
Cool. Well, I've covered pretty much everything I wanted to talk about. Do you have anything, Pascal, that you still
looking at the beautiful mind map that Darlene made for us as a canvas of discussion. I was looking at effective practices in software security. I think we talk a bit about a few things, but I don't know, anything you would like to have, like for instance, when we talk about DevOps, most of the time people know DevOps. They don't know much about DevOps. They know about CICD and automation. That's all they think about. How, from your perspective, and it's a trick question because I kind of know the answer, but I want to have your take on that one. Is building a CICD the utmost important thing you need to do if you want to be in a DevOps culture?
Yeah, so you're mixing. So again, like I said before, you have the culture part and the architecture and the tooling part, right? And they're very symbiotic. So if you just build the tooling and you don't have the culture, you're not DevOps, right? If you just have the culture, but you don't have any of the tooling, well, you're not DevOps either. So really, for me, DevOps is built, I used to use this diagram of like a pyramid to say, in my mind, what it was built on. This is kind of like when I first discovered there was even a term for it, right? But I mean, again, virtualization and the ability to shift left on test automation was huge. It's a huge turning point, right, in software with what you can do earlier on. User experience, another really important one, I think is very important from DevOps, understanding how your software is used, how it's consumed, and taking that feedback, right? It's a lot about the feedback loops. And then also sharing that pain of, you know, you're all on board until things are running in production smoothly. And if you take it even like Google does with their SRE teams, right? Sometimes the teams who did the service are actually monitoring their service. They're the ones who get the pager, right? And you know, Google, people will joke like, you know, code quality got a lot better when developers started carrying pagers.
But it's true.
So yeah, because you feel the pain. It's a lot about empathy, right? And when I started using that word like 10 years ago about empathy, people would look at me like, we're in software, are you crazy? Empathy, like this is whatever. But now it's like a pretty ubiquitous word. It's really about understanding your customer, understanding how they use your services and understanding their needs. And then also sharing that central goal, right? That we've created value for the company when our code is running in production, you know, securely with quality. And that should be all of our goal, even if you're in like HR, or even if you're in finance or whatever other part of the company. This is how we make money, and we should all be trying to work towards supporting that in whatever way we can. But maybe I just gave you a really fluffy answer to your thing, but I think that DevOps it's both. It's culture and it's the tooling and the architecture. And with only one of those elements, you don't have the full benefit. DevOps as a term, it's overloaded, just like Agile got overloaded, right? DevOps becomes like this DevOps engineer term, like I need a DevOps, and it basically means you need someone who does cloud orchestration. I mean, that's basically what it's become, right? Or somebody who it does like your pipeline or like whatever. To me, that's not what DevOps is. That's just a tool and enablement, right? To be doing, to be building more of the automation that's needed to put the features into production faster with security and quality.
So we both agree, we all agree, I guess, that there's no DevOps team that take care of the pipeline.
So that's an interesting point, right? Like, so it depends on the size of your organization, and I've seen different models. Some organizations, like Spotify's one, they have a cloud engineering team. They have a cloud engineering team that builds tools that the development teams consume, right, or use. Does that model scale better than stretching things out across? It depends on the size of your organization, right? If you're a 2-pizza team, I would say everybody in there should be doing infrastructure as code. Everyone should know what infrastructure as code is. They should know how to write their Jenkins jobs or their Git jobs or whatever it is to do their automated test, full stack, right? And they should all be participating in the always green. So it should never be just whoever. It's never that one guy who always like will look at the Jenkins failures and be like, oh, I'll go fix them and figure it out. It's whoever looks at it first, right? It should really be that. But if you're in a large organization like a Spotify or something, you might want to pave road some of your tools, right? You want the development teams and the developers to be able to use what they need to get their job done. But you also want to offer some paved road tools and scale those out across the company. And that's a decision that they've taken. So do you call that a DevOps team? To me, it's not a DevOps team. It's a cloud engineering, or it's a pipeline team or something like that.
And I agree with your description. What I meant was, you know, when you don't deploy your stuff, when you don't do create new jobs in Jenkins, I do agree that dev teams in a sizable company won't never have to install a YAS or a PaaS or do orchestration of some sorts, or install the Jenkins, for instance. Those things has to be delivered by operations as utility. You know, I want electricity. I want my monitor to open when I click my button. Well, I need to plug it in the wall, and I have faith that electricity would power my my monitor. I think it's the same. Those, you know, having your pods, your instances, or whatever you call them, your VMs, you should rely on the fact that other people, operations, cloud, whatever, have been working very hard to put that in place for you, and you can use them. But you have to be knowledgeable enough. You know, the intersection between dev and operation is, to me, it means that you need to be knowledgeable enough to be able to configure them and to deploy them and use them.
And I don't think you should have to call the ops, the whatever we're calling the people who actually do I don't think you should have to call them every time you have a new idea. There should be an infrastructure there that should allow you to have a new idea without having to bring them the people who know the cloud in every time, because then at some point you become again dev and ops. I think I should be able to deploy my stuff. It should be magical, for use of that word. But at some point, if I have to call somebody in another team every time I want to do something, then you're probably doing it wrong.
But not too magical, though. not too magical.
No,
Because
no.
I want the person to be able to say, it's not working this time. Maybe I should have a look at the logs. Maybe I should try to, having basic understanding of what you have control and what you can do. And then if it's outside of that scope, well, then you reach out to someone who's very knowledgeable. It's same with security. You do your basic maintenance, your hygiene stuff. And then if it's not enough, it still smells, you go and you ask for someone who's very knowledgeable about it.
Yeah. I mean, it depends. I think like that. I agree 100%. I mean, every company will have their own definition of done for their teams, right? For me, the golden standard is that your definition of done is it's running in production reliably with security, and and you're owning the any issues that come through, right? As a team. To me, that's done. And that you have the competencies in the team to deliver that feature, or you bring them in to help you, but you don't hand it over. You're not waiting for external people, because then you're actually breaking fundamental rules of Agile, right? Of Scrum. If you're reliant on somebody outside your team to be able to deliver, well, that's actually really not a good Agile practice, right?
No.
But it, in reality it happens, but we should minimize that.
No. Yeah. The reason I like your definition of done is that, and I've had arguments in places where I've been before. The reason I like it's because it's simple and it's clear, because I've worked in places where they were having discussions on what is the definition of done. The definition of done is if your code is finished and you've done your unit test. Yeah, but it might not work in integration. So are you done when you've done that? Should you sit and wait until integration testing has been done? And you keep going into these weird circular discussions where, no, it's done when it's in production, but you can't do that if you don't have an efficient pipeline to deliver to production.
Exactly.
And that causes, but those discussions happen in financial institutions all the time. It's annoying because there's so many steps that you need to go through and nobody's willing to automate them.
Yeah. The other challenge though with having that pipeline and having the confidence in the pipeline is a lot of if you haven't done this from the beginning and you're not a Facebook or a Spotify or a Netflix or whatever, right? The unicorns we often hear about, it takes time also to build the trust, right? Because if you're going to push through, stuff that's going to break, especially on a financial institution, if you're going to push through code that's going to break the app on everybody's phone that they're doing their banking with, and the recovery time, because you don't have a really nice, robust pipeline that you can push things through quickly with the quality, means your time to remediation, like your MTTR, right, is going to be really bad too, which means you can't recover. And that's where, like, if you look at Netflix running their Symbian army, right, like on their production systems, what that is so powerful about, it's not like, oh, they've got the balls to do that. It's like you have to, and people who are in software will understand the level of quality and confidence that they must have in their ability to recover if something goes wrong, to discover and recover if something goes wrong by running all of these, like, performance and whatever they're doing, break and destroy tests and everything on their live production system. It's incredible. And you have to have respect for that, to say that just speaks volumes. I don't even have to know about their development pipeline to understand that what they're doing, what it says about their development pipeline and their processes and the confidence that they have in it. So
exactly. And just a quick anecdote. I remember working in a place where they would merge once every 3 months and stuff, and it would break and then take another month and a half to sort of fix it. And I was on a team that was supposed to automate all that process. And I was working with a brilliant young man that I'm not going to name because it's going to name the company. But I was working with a brilliant young man, and he had done all the, and the only thing I gave as an instruction to the entire team when we started working was, I don't want to have any human intervention anywhere. I want this to happen automatically from A to Z, the merging, and you start the script. It doesn't need to be in a pipeline because we couldn't do that, but it needs to be a script that you start on your thing and then you go and have lunch and you come back and it's done. And so we started doing that. We started merging and started working. And so at some point, the guy decided, I'm going to be doing this in dev now. I'm not going to do the 3-month thing, the merge every 3 months. I'm going to do it like every day. And I'm going to run the compile of everything. And he started doing that. And we were in a meeting with a manager who was really, really frisky at that idea, right? He said, I don't think we can do that, we'll break. And it was him and another guy that were saying everything will break. And he's arguing that everything will break and the brilliant young man just sits there and he goes like, well, we've been doing it for a month and it hasn't broken. And the guy would like, and my response was, maybe we should buy some balls and just trust the development team. We're trying to make it better, right? Which is unfair because the guy was not an uncourageous person, but I was sort of tired of having like, it will break, you don't know, we can do better. You know, it's unfair to the guy, but he sort of recognized it when the brilliant young man went and said, I've been doing it for a month. He went like, oh crap, then I don't have anything, right? If it's been working for a month, then that's what we're going to do. And he sort of leaned into that after.
Trust is so huge. And so it's the keystone of everything. Like when I did Agile for the first time, it was in 2004. I was like freshly out of university, working. I can say it, I guess, at Deutsche Bank. So it's one of the top prime brokerage organization in the world, and we want to be more agile, to be able to respond more easily to changes and everything. But our boss was not really down with that. And eventually, well, we just decided to stop the conversation and do it by ourselves, for ourselves in the development team. And after a month or so, he realized that, oh my God, you guys are doing great lately. What's going on? And we revealed it. We said, well, we're doing Agile and like we wanted to, but it would be cool if you join in because we could go further. And then he was all in, but trust is everything. Like for tests, another anecdote from the Institute as well. You know, we were automating tests, a lot of them. But the problem is we had this this reverse pyramid at first, not enough unit tests, a lot of end-to-end tests, and then we had this hour-shaped glass because we fixed the bottom, but not enough integration tests. But still, they invested so much in the end-to-end that they wanted to keep them, but they were full of false negatives, and you know they were not reliable enough. So that harmed the trust so bad at the beginning. And we were like having people from the business redoing all those tests manually, even though we automated everything, because there was no trust in that test coverage we were implementing. So with time and decommissioning a bit of end-to-end and building more unit and more integration tests and showing that we were able to deploy, integrate, and more often, and blah, blah. With time and love and care, we built that trust. And eventually, I'm hopeful that now they're not doing the job twice, because it's very costly, but it's all about trust.
And that goes to the technical debt of test pruning, right? And test maintenance, because if you let it, and it's a discipline, it's really about having discipline. And people, who think agile is like all this like very I don't know, hippie stuff, like, oh, it's all loose and whatever. It's super disciplined, and the discipline to go in and every day and make sure your tests are working, and make sure if that test no longer works and it's giving you a false negative or a false positive, even worse probably, but a false negative, figure out why. If you don't need the test, get rid of it, right?
Yep.
But it's like, don't leave this like body of tests lingering around that maybe they're not even testing the right things anymore. Maybe that's, and because as soon as you get the red and you move away from the always green, and as soon as you get the red, and I mean, we've all seen it, right? You talk to someone and they'll be like, oh yeah, but that test doesn't work because, oh yeah,
it's
the
normal.
mock didn't, it's normal, right? The mock didn't get updated. We're waiting for it, but it's been like a year. And so at the minute you have that, it's that broken window syndrome that I think we all learned early in our careers, right? And you can't let the broken window syndrome take over, because that's when the debt it accumulates and accumulates. And the technical debt in all of those areas, but it's so disciplined to prune it every day, and it's hard.
Yeah, but it's part of being a craftsman and craftswoman, you know. If we had this discussion last week, JP and I, about craftsmanship, and we want to do a podcast on that with people discussing some form of table ronde or something, you know, to be able to exchange on that, because it's part of your values. If you want to be a professional, if you want to do things the right way, you need to take care of business. And taking care of business meaning it means that you're the owner of the code of whatever you're producing, whatever is your responsibility, and you need to keep that clean at all time and make sure that it will evolve in a right way, and always in good shape and being clean. Yeah, it's super important.
Yeah, agree.
Yep.
All right, I think it's a great note on which we could end this. I see that we still have a lot of topics that we could cover, so I guess it will be till next time, Darlene. It was very interesting.
I'm more than happy to come
discuss
back
with
anytime you want. Thank you very much.
I'm glad to hear that, because we'll have you back for sure. Well, thank you so much.
Thank you to both of you. Take care.
All right. Cheers.
Bye.